Why is it not showing here? Dang it. हाँ लेकिन यहाँ पे पता नहीं हो ही नहीं. ओके okay. Is it? Am I visible? Okay. Please be patient with us. We are having some technical difficulties. Please just wait for just 5 minutes. We'll be back.
Okay, we are back.
We are back. Thank you all for waiting. Thank you so much. So should we start?
Yeah, we can do.
Yep. Okay. Good morning and a very warm welcome to the World Seagrass Day 2026 webinar series themed Dugong Habitat Monitoring and Restoration, hosted by the Wildlife Institute of India's Campa Dugong project. Thank you for joining us, and thank you for waiting too so patiently, especially on a Sunday, a day reserved for sleeping in, doing laundry, and avoiding emails. We hope that this webinar series is exciting than our pending chores. My name is Samiha. I'm a spatial ecologist working on dugong foraging ecology and tidal vigilance. I'm a project scientist with the WII's Dugong Recovery Program. It's my privilege to serve you as your host for today's session. On the behalf of Director Dean PIs and co-PIs at the Wildlife Institute of India, extend a very warm welcome to all of you. Throughout the course of the week, we'll be talking about one of the least recognized marine habitats, Seagrass meadows, which quietly underpins so much of the coastal world we care about. They stabilize sediments, they support fisheries and millions of coastal fishes. They're an excellent source of food, refuge, nursery for organisms across the trophic levels, and lock away tons and tons of carbon for centuries. Yet many of us working in the Southeast Asian region are experiencing that these meadows are changing faster than our monitoring programs can often keep up. For dugongs in particular, every hectare of lost seagrass is not just a habitat loss, it's a lost foraging opportunity, which leads to lost reproductive health, which ultimately leads to population decline. Throughout the week, we'll learn why do we have to monitor seagrass meadows, how do we effectively monitor them, how do we protect what remains, and how do we restore what has been lost. We are delighted to have researchers, conservationists, students, and practitioners joining us from across the Southeast Asian region. This week-long series brings together some of the most important and active voices in seagrass and dugong conservation science, from habitat mapping and dugong population monitoring, seagrass habitat threat assessment, and of course, restoration. By bringing together researchers from Thailand, Malaysia, India, and beyond, this webinar series aims to create space for the kind of cross-boundary dialogue where methods can be compared, failures are shared as openly as our success stories, and solutions can be co-developed. A quick note for our audience: the first 10 to 12 minutes of each session will feature a short contextual presentation by our team at WII, setting the stage for our guest speaker. Please drop your questions in the chat throughout the talk, and we'll take them in the Q&A. The session is live streamed painfully at WII's YouTube channel. Do share the link with your colleagues and network. And I invite my colleague Shabni Bose, who is currently pursuing her PhD on persistent organic pollutants in seagrasses and associated benthic fauna. She'll brief us about the status of habitat distribution and threat assessment of seagrass meadows in India, and formally welcome our guest speaker, Dr. Milica Stankovic, whose challenging work on seagrass meadows as carbon sink has been long admired and from whom we have so much to look forward to learning today. Over to you, Shabni.
Hello, am I audible? Hello, am I audible? Am I audible?
Yeah, you are. You are. I can hear you.
Okay, thank you. So, good morning, everyone. Thank you for the introduction, Dr. Samia. So, I am truly honored today to start this series of the World Seagrass Day. Over the next 4 days, we will understand and the more about the vital yet understudied habitat. So, what seagrass meadows are the underwater flowering plants which have adapted completely we are completely adapted under the sea on saline water. These have a lot of ecological significance. It covers most around 0.2% of the ocean, global ocean, but contributes over 10% of the carbon sequestration. So these can be known as the ocean's quiet climate alley. current status of seagrass of Southeast and Asia and Indian overview is that in Southeast Asia, 21 species. Southeast East Asia is one of the global hotspots, and which covers around 36,000 kilometer. And the studies have shown a mean loss of 5% every year since 2000. And in India, there are 15 species, 16 species known, with an area of 516 square kilometer, with approximately mean loss of 9%. But these studies were only from 2001 to 2012. Recent studies are not been done. Looking at the current status, these meadows are under intense threat. The major or the most primary threats we can see is the coastal development and land-based runoff, the dredging and sand mining, land-based pollution and sedimentation, fisheries, boat pressure from anchoring, propellers, and tourism. And the one of the most silent threats are the solid waste and plastic dumping. From those waste, chemicals releases that are maybe not seen but are binding to the ecosystem and harming the seagrasses. This brings to the heart of our project, our work. Though we work on dugongs, we well know that without conserving its habitat, that is seagrass, it is not possible to save the animal. So our project's one of the major objective is habitat conservation and management. We have been working from 2016 till now, and we have been using an integrated approach where we have combined ground truth field surveys, remote sensing and modeling, citizen science to understand, to see where the seagrasses are, how the dugongs are using the seagrasses, and how much pressure is the seagrasses facing by the use of the way the humans use. And we are also looking into the finer aspects like to assess the habitat quality, like nutrient analysis, nutrient understanding, the pollutants, and the other macrobenthic faunal assemblages. We From this, what we have got a very nice and very robust data on understanding like 18 foraging grounds, 18 foraging grounds of 4 species in Gujarat has been highlighted that you can see. And in Andaman and Nicobar, we have discovered 32 new meadows with 11 species, and whole Park Bay and Gulf of Mannar have a huge continuous seagrass patch that we have mapped of all 15 species. Not only mapping the seagrass and identifying the area, we have also identified the threats. We have layered the boat traffic and the macroplastic data to get the high risk areas of the dugong habitats. That is seagrass, because dugongs are only like found in the sea. Their feeding grounds are the seagrasses. Further, the habitat assessment, health assessment, we have done PCBs and OCPs basically currently with seagrasses and sediments to understand the things that we can't see, like the boat or the plastics pollution we can see, but things something like these things we can't see yet. It is a very big threat to the area, such a luscious, good, important, vital area. So we have found in seagrasses, PCBs and has already exceeded in Gujarat and Tamil Nadu. In sediments, everything, the PEL and TEL, the threshold and probable effect values has been exceeded. That has a very risk to the animal, the biota there. So our project in India has shown that the mapped seagrass meadows supporting dugongs are vast, though vulnerable to directly under industrial agriculture and climate change. In this context of rapid seagrass change, it is critical to understand not only where meadows are disappearing, but also what that means for stored carbon and climate mitigation. It is our great privilege to welcome Dr. Mititsa Stankovic from the Dugong and Seagrass Research Station, Faculty of Science, Prince of Songkla University, Thailand. Her research spans from seagrass ecology, blue carbon satellite, and UAV-based habitat mapping to nature-based solution for coastal policy. We are truly honored to have her with us on World Seagrass Day. Though her work, we will learn and understand answer to simple questions. How much carbon do Southeast Asia really hold and what happens to the carbon when these meadows decline? Dr. Stankovic, please take it away with your talk. Thank you.
Thank you. Thank you so much for having me here and for such a wonderful day and opportunity to present part of my work and what has been happening in Thailand the last couple of years. So let me just share the screen. I hope you can see the slides. Can anyone confirm if you can see the slides? No? Wait. Oh, sorry. Okay, hopefully now you will be able to see the full picture. Okay, here we go. Sorry, technical difficulties. My work has been on the seagrass ecosystems for more than a decade now. All this time I have been based in Thailand, but in the recent years, I started working more on the regional level and looking the regional patterns of the seagrass. Trends, statuses, blue carbon, where my main focus is, and how we can interpret these changes and include them into the policy framework and continue protecting and restoring these ecosystems. So for today, I would like to introduce you and talk about what has been happening in Thailand. And how the loss of and changes of the seagrass affect carbon, but also the other ecosystem services. This is example one. This is an example on what can happen across the whole region. As far as I know, a lot of countries in the region have been experiencing some kind of a decline. So just a brief introduction that has already been mentioned why the seagrasses matter. So besides all of this has been already mentioned, they support nature in terms of the global marine biodiversity, people in terms of the small scale fisheries and coastal livelihoods, climate in terms of the carbon stocks and stabilization of the sediment, and of course we have to mention food and habitat for dugongs and other marine life. In Thailand, seagrasses occupy Andaman Sea and Gulf of Thailand. So Gulf of Thailand is part of the South China Sea, and Andaman Sea is connected to the Indian Ocean. We have about 13 species, 12 on each side of the coast. Majority of the species are occurring on both sides of the coast, or were occurring on both sides of the coast, with exception of Rupia maritima, which can be only found on the Gulf of Thailand, and Halophila major, which can be only found in the Andaman Sea. But the other species can be found throughout the coastline. And these meadows are very critical for local fisheries, their livelihoods. There are a lot of communities really depend on the livelihoods from the seagrass ecosystems. In addition to that, in Trang province along the Andaman Sea is the key dugong habitat that supported the second largest dugong population besides Australia. Now the dugongs are a bit scattered around, but you will hear that or hear more about the dugongs in the next talk from Thailand team. So the loss of the habitat actually influences on several levels, and it's national. It's not only the small scale problem anymore, it's a national and as well the regional concern. So we are currently targeting Thailand as the priority country for seagrass conservation and potential restoration on the large scale. So this is the picture from one of our study sites actually. And in 2016, you can see it has been very healthy, green meadows. And this site is one of the is the second largest seagrass meadow in Thailand. By 2021, we actually observed quite a lot of changes in the sediment, species composition, distribution, and so on. And by December, a lot of seagrass has disappeared, and it was completely gone. And all that was left was barren sediment. And this is not a single case example for the seagrass in Thailand, and many parts of this many seagrass beds along Thailand have been affected similarly, not drastically like this, but in a similar manner. And there is a serious decline in many of them of the cover condition or the continuity where they became severely patchy with only few patches spread across the area. Excuse me. Across the area where and once there was very continuous and lush meadow. And besides these very visible changes, we observed the losses of biodiversity, fisheries, habitat quality, human livelihood, and of course, carbon storage. So with these severe changes of the seagrass loss, we are experiencing the loss of ecosystem functions. So there are these drastic changes. This is the picture again from one of the sites. This is just before the complete loss of the meadow. And these drastic changes have been mostly located along the Andaman coast. At first, they've been very visible in Trang province, in Libong Island, where most of the dugongs are. And then it kind of spread north and south. And it is reaching almost Myanmar and Malaysia. And these changes are very, very visible, not only from field observations, surveys, and remote sensing, but also the local communities, government monitoring programs, and so on. So everyone is on board and seeing these changes in the last 2-3 years. And this pattern, I would say, was serious enough to require urgent management attention from both local communities, government, local government, national government, and so and it became a national concern. And in the last year or so, there has been a lot of talks on what are the proposed actions of how we can manage these losses and conserve what we have. So in terms of the lost carbon, just a short overview. The seagrasses, they store carbon in 3 different parts: in the leaves, roots, and rhizomes as below ground part, and the sediment which they occupy. The carbon in the sediment is the major part where the carbon in the seagrass ecosystem is. So losing seagrasses, losing or when the degradation happens, the stored carbon becomes more vulnerable to disturbance, erosion, and loss. through oxidation of the sediment, and then emissions to the water and to the atmosphere. So with these kind of theories and definitions, what we have been actually doing is actually checking the meadows, because for the last 10 years we have been working on the blue carbon in Thailand, and we have a really good data set from several years ago. I think our first data set on blue carbon dates 2015. And we have been noticing a lot of changes, especially in the sediment. So, for example, when the seagrass meadows were very healthy in 2015, 16, 17, we recorded the sediment organic carbon stocks up to 128 megagram per hectare as the average carbon stock. As I remember, the highest one that we recorded was almost close to 200 megagrams of carbon per hectare. So it was very, it is very carbon rich. We have very carbon rich sites. And as the years progressed and the degradation started to happen, in last year, we actually finished the data collection and the revision of many of these sites, which resulted in very depressing value of the carbon across almost all sites that were affected by the seagrass degradation and loss. So I think in one of the lowest one that we observed, the carbon in 2025 was about 33 megagram per hectare, which is drastic decline compared to 100 and something almost 10 years ago. Besides the carbon stocks, we started recording the fluxes, greenhouse gas fluxes, especially carbon dioxide and methane, and which was surprising to us. We had the highest, the methane emissions were the highest compared to the CO2 emissions. And of course, when we compared across the different states of the seagrass, between degraded, healthy, bare sand, I mean, we can still find healthy seagrass here and there. The highest fluxes were in a degraded seagrass. And besides that, we noticed, we defined that most of our seagrasses that are degraded or severely degraded and lost are actually a carbon source right now. So they shifted from carbon sink from several years ago to carbon source. We actually defined the value where we still know that the patchy seagrasses are still carbon sink, but then at certain point they shift to a carbon source. And we are currently working on defining that boundary where we can see the shift change from carbon sink to carbon source. I selected 3 of these sites as the examples of what has been happening in Thailand and in terms of seagrass degradation and how it affects carbon. So all 3 sites are across Andaman coast, which is the west side of Thailand, and they are spread out differently. So Libong Island is the second largest seagrass meadow in Thailand. Yong Lam is the largest seagrass meadow. So Libong is the second largest meadow, and it was the first one that experienced decline and losses of the seagrass. So when we compare the carbon changes, we also noticed that there is a highest loss of carbon at this site from 2015 until 2021, with about 16 megagram of carbon per hectare per year being lost. In 2025, the local NGO, with the help from the researchers from our lab, conducted several experiments, and they noticed that there is a certain degree of seagrass recovery. And we also measured that, but in terms of the carbon, but the rate of recovery is really small, and it is mostly halophila. So that carbon that is being recovered, most likely it's not a long term, but at least there is some recovery and a positive note on very sad story. The second site that I selected here is Yonglam, which is in the national park, and that is the largest seagrass meadow in Thailand. So Yonglam is a site in the national park, and it's the only seagrass in the MPA in Thailand. That experienced a partial loss between 2021 and 2025. Although the seagrass meadows are very sparse, very few species. This is the example of what we actually found last year, mid last year, and it was just Halodula, and that's it, and very sparse Halodula species. Compared to several years ago, compared to 2021, when you had very continuous lush meadows with, I would say, 5 to 6 species co-occurring together. Shift from that to just simple Halodula with some Halophila patches is a huge shift. But in terms of the carbon loss, there has been a partial loss, not as high as Libong, the neighboring seagrass bed, which is Libong. So just some seagrass, some carbon has been lost. They're not as high as Libong. And the third site that I included in this presentation is Tan Khen Bay, which is in Phuket. And that is further north from the previous two site examples. And through there, in that area, there was very small changes of seagrass loss and degradation. Most of them were seasonal, as the degradation of seagrass progressed, the government kind of designed some special management and monitoring in this site to try to protect it as much as possible. And they had, as far as I remember, they had a lot of cages. You will see on one of my slides later on, and they were rotating the cages throughout, so the meadow can actually recover. So in this meadow, there was actually no loss of the carbon at all, even though there were some changes of seagrasses and some small declines. Overall, it did not affect any changes in carbon from 2015 until 2025. So what is actually driving this decline? In our case, it is the cause of all the pressures combined together and not a single factor. We actually still don't know what is the cause of the loss, but most likely it is the combination of all of these factors together. It got triggered with the reduced light availability. And then it accumulated with the human activities, high sea surface temperatures, and changes of tidal level, because you have more sediment coming in from the nearby rivers. So the tide exposure during daytime was much longer than before, and the loss, the seagrass loss actually peaked in 2023, 2024, where I think we had a very hot summer at that time. And of course, elevated nutrients. And on top of that, because the seagrasses have been declining quite a lot, the animals became very hungry. Green turtles and dugong started to eat everything that they found. And that was, I would say, cherry on the top that kind of degraded or lost the whole ecosystem. But we don't have the specific knowledge on what factor was the key factor in the degradation, and how we can resolve this. So currently, we are hoping that within this year or next year, to work on using them to try to identify which factors from all these were the key for seagrass degradation and loss in Thailand. But currently, in terms of these factors, they kind of stabilized, and the seagrass recovery started to occur in many of the sites. In most of the cases, Halophila is the only one that is returning right now. But again, Halophila is the opportunistic species and kind of sets the stage for the rest of them. So I think we are having we are progressing in advance in terms of the seagrass recovery, but we are not there yet. So in our case, the seagrass loss is very hard to reverse and to have the seagrass bed return as it was. Current recoveries is very slow, uneven, and uncertain. The picture that I have here is one of the cages that local community, universities, and government started to set up across several meadows in Thailand. As I mentioned, because animals were eating because they were hungry. Not blaming any animals here. So they were setting up just to save some of the seagrasses so it can start to spread around. And that effectively worked in some sites, and some sites did not work. So these kind of cages were, the poles were just above the water level when you have the high tide. So no animals can actually jump in, and the top is open. In some cases, the seagrass started to expand beyond the cages, but from the recent reports, there has been, because there is some recovery of the seagrass in some sites, for example, Libong. The cages have started to affect the water flow, and I think the local communities is trying to take them out. So even when these pressures are the pressures that I mentioned before are reduced, the seagrass are not returning very quickly. And currently in Thailand, we do not have any large-scale restoration programs. We do have small-scale restoration and recoveries, but nothing on large scale that can help these kind of the losses on such magnitude. So currently what we are working on is combining the technology that we use basically for monitoring to start detecting the seagrass losses, to go beyond detecting only seagrass losses. So we are trying to detect how much of the seagrass we lost so far, but we want to go beyond that so we can start implementing and defining guidelines for early responses to support earlier and more effective response to the seagrass degradation and loss. And we are combining high resolution satellite imagery, drone surveys, and also the ground truth data from the government, NGOs, and local researchers into one. So hopefully that is happening this year, and we will have a kind of a guideline that with the government set up to start to see if we can effectively use this for any future changes. So in terms of what we are doing next, we are trying to find the priority sites in healthy meadows that we are going to protect, not only for the seagrass, but also for the dugongs and other ecosystem service and dugongs, turtles, and other ecosystem services that we can actually use as the sites for restoration. We also try to prioritize the high-risk areas that need the most attention. Although Libong, the case of Libong site, Libong Island experienced the highest loss of the carbon and seagrass, the seagrass there started to return, but in some meadows, there isn't any return yet. So in those terms, we are trying to prioritize the areas that need that need the highest management. And of course, we are trying to find a way to restore the seagrass. And again, I have to mention the restoration on large scale, and I'm hoping to learn more from the talks, from the next talks from India and Malaysia. And of course, next part would be the monitoring, just continuous monitoring of what have ever been doing so far, just continuing it with drones and incorporating the remote sensing part. And what finally we are trying to do it is connect it with the climate and coastal policy and biodiversity. Climate, coastal, and biodiversity policies onto the highest levels, so we can start protecting these ecosystems across the whole country. As the final thought, on this day, this World Seagrass Day reminds us that protecting these meadows actually means protecting our future coasts, food, biodiversity, our livelihoods, and so on. So if you want to know more about my work or anyone from my lab, I left my email here. So you can just send me the email. Thank you so much.
Thank you, Dr. Milica. Thank you so much. We do have a couple of questions. So Chinmay here asked that what was the structure of seagrass meadows in Thailand historically? Are the seagrass losses you mentioned also affect the deep subtidal meadows? We generally know that if a degradation mostly happens, it starts with the intertidal. So this question is about shifting baseline and composition.
Yeah, but so the problem is we don't know where our subtidal meadows are. We do know some, but majority of the seagrass meadows in Thailand are intertidal, and that's from what we know. It might be that we have more subtidal meadows, and that is actually happening when the whole degradation started. And when the dugongs and turtles were starving, a lot of divers were trying to, like on the random dive, post the photos on social media. Oh, you have some subtidal meadows, and they look very healthy. So far, we don't really know where our subtidal meadows are, but we are trying to map them. We do have another project that is mapping subtidal meadows. But to specifically answer your question, from what we know, from again those small social media photos, the subtidal meadows are not yet affected.
I hope they remain that way.
Yeah, let's just hope that they. I mean, the dugongs and turtles were feeding somewhere. So I guess that there are some subtidal meadows, but we just don't know where they.
Yep. It just goes to show how important spatial distribution mapping is, actually, how important baseline and long-term monitoring programs are.
Yeah, exactly.
Our next question is, do coastal protection structures such as seawalls and points impact seagrass ecosystems? If so, how can coastal protection be balanced with seagrass conservation?
In our case, not really. We do have some seawalls, but they were not affected specifically the seagrasses. But our seawalls were built many decades ago. Um, but currently, we don't have anything that is being built. But I do know the cases from the nearby countries, such as Malaysia, when you do have these kind of structures, that it does impact the seagrasses. And especially because you are building one and it reduces the light availability. And it just starts with light availability, and then all the other accompanying factors with the nutrient runoff and so on, and it just starts to degrade the meadows.
Yeah. Especially for intertidal meadows, I mean, you basically with seawalls, you basically change the regional hydrodynamics of the place, which
Exactly.
inevitably is going to affect the local meadows.
I know in terms of adding on, there are, in terms of the balancing the nature coastal protection, there are examples of use of not seagrass specifically, but mangroves, together with the structures to create the green infrastructures, to balance the sea level rises and the protection of the coast. I think there were few examples from Singapore, and also Japan. They are trying to explore these options to protect their coasts.
It's also, I think, better for the tristic ecosystem that we have, corals and seagrasses and mangroves. It keeps the integrity of nursery habitats too.
Yeah, exactly.
So our next question is, because of the degradation, are there any visible decline in the available of dugong population in the area? Yep.
Yes. Yes. The dugongs were very visible, malnourished, and that created a national, I don't know how to call it, a national boom of people and citizen science who want to know what is happening with the dugongs. And I think you will hear more on the 3rd March about that. I don't want to spoil anything from the next talk, but yes, there were visible changes in the dugong.
Yep. I mean,
Yeah, I don't know.
Of course.
There is a lot more to
That's
talk about. Yeah, there is a lot more to talk about this topic, but I really don't want to spoil anything from the next talk from New.
Okay, we'll keep it for Dr. New then.
Yeah, you can keep it for the
we'll
next
keep it
talk.
for New then. We'll keep it for New. All right. Okay. Another question is, you mentioned Yanglam Meadow has a protected status. What could be the reason for such a drastic loss despite its protected status, and what pressures can still be managed by RPA managers?
So it is part of the MPA, and Libong is part of the wildlife sanctuary. So both of these meadows were the first one that were visible, that you see the visible changes of the loss. And from what we gathered was that different meadows were affected by different combination of factors, and different meadows had the different key factors that kind of started rolling over the loss and the changes. With the Yonglam, because it was a protected area, it kind of it was so strange, because in the matter of a year and a half, the whole meadow was gone. And it basically, there was nothing that any of the managers could have done, and it wasn't that there was anything being built. It was just the continuation of degradation across very, very large scale, and most likely it was from the climatic factors.
I mean, more often than not, it's just not a source point where you can put your finger on it. This is what causing the degradation. And especially if there's climatic changes, there's this increase in sea surface temperatures and sea surface levels. SLR, sea level rise it causes ultimately, depletion in light that we need for keeping up with the growth. I mean, even if your seagrass is there and visibly there's no visibly not degraded, it does not mean it's not
Yeah,
under
exactly.
any kind of stress. So I mean, you did mention that it took you a long time. I mean, almost a decade. I congratulate first of all for your work. I mean, it takes
Thank you.
it takes kind of pressure. It takes resilience to stick around for a decade and more than a decade to keep on advocating for these habitats. But my question to you is. I mean, it was quite alarming when you said that it's moving towards Malaysia. It was just first, visibly, seen in Thailand. It's moving towards Malaysia and towards Myanmar too. I wonder how many, missed long-term monitoring that we have done, like it's probably affecting the Indian subcontinent too. So my question to
There
you
are
is,
there are very few. Sorry, there are very few long-term monitoring.
mm,
I know that there is a long monitoring program in Penang, which is just below the border. And I'm very keen to see their results. I know that I discussed with them, and they also see not severe changes as us, but they've seen degradation. And I'm just waiting to see to see their paper coming out, or to see how they can write it up and publish it, because we really do need really long-term monitoring data sets to start
yeah.
including.
So, what advice would you give to the early career researchers, especially working in seagrass habitats? I mean, a lot of them are working in right now in the intertidal habitats of Parkway in southern India, and they're working extensively on restoration. So, what advice would you give from your experience about, like, suppose we don't have that kind of the privilege of working on for a long term? What are the immediate signs? I mean, you can, just because we know we
But
talked about
starting up, but starting up,
about
um,
yep,
sorry, but just starting up a monitoring program. It doesn't
yeah,
matter if it is long term or not. Just starting up something in those terms, just in the basic data sets, it will benefit. It doesn't matter if it is not continuous for the 10 years or 20 years or so, but just a matter of having some data here and there. It would be very, very beneficial.
What's the most effective markers? I mean, you've worked on net community protection. I mean, production. You've seen like we want in an ideal situation, we want to see the balance between carbon sink and carbon source. We
Yeah.
want to see that balance. Yes. So what advice would you give to early careers? What should they estimate the NCPs or the greenhouse gases emissions? I mean, how do we see a meadow? What estimates should we go for to see if the meadows is almost degraded or on its way to be degraded?
The NCP, the NCP and the MPP.
Yep.
They were those factors actually gave us where the shifts between sink and source, because even though even healthy seagrasses, they do have emissions. Sometimes it can be high and nothing is happening to the meadows. So these kind of NCPs and NPP were the ones that actually showed us that they were shifting from sinks to sources.
Yep. Yep. Also, one more question we have here. You mentioned about the lack of sunlight as a reason for degradation. As sunlight and visibility is a major factor when it comes to drones, so how effective are drone surveys and seagrass monitoring? Can we detect seagrass decline through drone monitoring?
Yes. I currently because we currently don't have the full scale of the seagrass loss. So what we pulled our drone surveys, and across all the meadows and all the years, we just set and pull all of them together from different NGOs, government, and so on, and we started looking at those changes. So simple as that. So the drone is super helpful because you can fly anytime, any time of a day. It's best to fly, of course, during the lowest tide, but it provides you a continuous data. This and it's a low cost, of course, if you look at the long-term scale. So my suggestion in those terms, it is very effective. We currently have a paper coming out where we use the drone actually to quantify these changes of the loss.
Yep. But the thing with, I think, with the drone surveys is that you can only estimate changes once the damage is done. I think. I mean, the physical changes. Yes. Is it necessary, or you can also like detect some kind of, if the meadow is in stress, can you see visible changes?
Yeah, you can actually, you will see the patchiness. That's one of the factors. That's one of the key factors. Is the meadow continuous, or is it the patches? Or the another what we did, for our, we kind of designed, the quadrats, the plots, the same kind of plots that you put on when you go on the field, to monitor the seagrass health in terms of the seagrass length, coverage, and so on. So we did the same thing with the drone data. We put the plots, and we were looking at the patchiness of the meadow, the composition. You can do some species because, in some cases you can actually really see the species, what species it is. So those kind of information you can get from the drone. And if you have a permanent area that you monitor, or permanent quadrats, that can become very good, long-term data set.
I mean, the key is collaboration and long-term monitoring.
Yes.
Okay, one final question for you. It's a bit uncomfortable. So we know that funders are mostly interested in funding you if you're working for, blue economy or blue carbon, right? You can get like relatively easy. You'll get those kind of fundings. I mean, but we know, and your study also shows that restoration does not always mean that. The restored meadows will be as effective as carbon sinks, but they're good for herbivores. I mean, it will still be an active foraging areas for both green sea turtles and dugongs. So how do you find the balance? You want the funds, but you also, cannot justify the carbon sinks.
I know. A lot of, actually, funders, because we had a lot of funders coming in and saying, "Oh, we want to restore seagrass. How many credits we can get?" And I disappoint them. I have to disappoint them, but because currently there is nothing else that will fund it. I mean, that will give the funds, in return. But there is a development in terms of the biodiversity, biodiversity credits, or nature credits, or just payment for ecosystem services. There is moving forward in that direction, than just paying for the carbon credits, because the meadows that we've seen, they are very healthy. There are seagrasses there. There is a lot of fish. There's sea cucumbers, sea stars, and so on. People go there and fish. There is no carbon there. It might take more than 10 years, for the carbon, or it might be just the meadows like that, and that's something that we don't know yet. So I try, to negotiate with them that the conservation right now is the way forward, or looking, for, like biodiversity, like net gain of the biodiversity, and things like that, than just focus specifically on the carbon.
Yeah. All right. It's a game of patience, really.
Yes.
Patience and negotiation.
Exactly.
Thank you, Dr. Maritza. I mean, even if it's restored, I mean, there's a difference between restoration and rehabilitation. Even like that's why I keep on stressing on for your early careers to work on shifting baselines. We need to understand what it historically looked like. We need those maps. We need those information to move forward, even so that we can realistically go forward if we want to rehabilitate an area or restore an area, because just because there was certain composition of seagrass does not mean you'll get the original state. Sometimes
Yeah,
you can
exactly.
the best you could do is just
Yeah.
halophila, the fast colonized.
Yeah, I mean, it is what we have right now, just with halophila beds. And with that, some of the ecosystem services are returning, which is great. But we don't know what will happen, what will be the future, because the loss has been on such a large scale. Majority of, for example, in halos is lost across the whole western area, whole western coast. And even if you go further up north to all the way to Myanmar, there are very, very few patches that you can find. And it comes back, okay, so if you want to do the restoration, where are you going to get it from? Where are you going to get the donor
Yeah.
plant? Because we had a specific genetic diversity, we have the different genetic diversity on two coasts. So bringing it from the Gulf of Thailand to the Andaman, it might not work, because our tides, our coast geomorphologies are totally different. So it's really a big question what is going to happen. It might not never be as it was before.
Yep. Yeah. All right. What's your favorite seagrass? And to that will end. I promise. What's your favorite seagrass? Non-problematic.
Yeah, I don't know. I never thought of that. Well, most of my work is on halos, but I don't know. I like Thalassia.
Ah,
Yeah.
all
Why?
right.
I don't know. I never thought of it. Most of my work was in halos. I'm not really fan of halophylla. It's too hard to clean. Uh, I don't know.
Oh, that hurts me.
Sorry.
That's my favorite.
I'm so sorry. Yeah, just in terms of when we were collecting biomass and cleaning it, halophylla was a nightmare.
Yeah. Yeah.
Just
Dr.
from the
Melissa.
carbon perspective person.
Yes, I think that is the reason you hate
Yeah,
halophila. I
probably.
mean, they're bad carbon sinks.
Yeah.
Thank you, Dr. Melitza. It was lovely talking to you. I hope our viewers have also learned something and took something away from here. You know where to find her. You know where to write to her. Thank you so much. It's been lovely having you and chatting with you about your work. I hope to some your project gains another level of scalability, and I wish all the best to you and to your entire team. Thank you once again.
Thank you. Thank you.
Yeah. To that, we'll end this session with Dr. Melitza. Tomorrow, we'll be having a talk with Dr. Mutahara Zakaria. Everyone, please attend that too. It will be as lovely and much informative to us too. Thank you, everyone. With that, we end.